everyone, this is Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equations with variable coefficients. So let's get going. Problem solve x square y double dash plus 3xy dash plus 5y equals to x cos log x plus 3. Given differential equation x square y double dash plus 3xy dash plus 5y equals to x cos of log x plus 3. We are given a differential equation which has variable coefficients, right? We can write this y double dash as d square y by dx square plus 3x into, write y dash as dy by dx plus 5y equals to RHS part. We know that d is a differential operator whose independent variable is x. Likewise, d square is d square by dx square. Now we can write this equation as x square into d square y plus 3x dy plus 5y equals to x cos of log x plus 3. Now take y common from all these three terms. We'll get x square d square plus 3xd plus 5 into y equals to x cos of log x plus 3, which is a Cauchy's equation. Now we are going to reduce this Cauchy's equation to higher order linear differential equation with constant coefficients. Simply by making a substitution, x equals to e power z, then log x equals to z, and let theta equals to d by dz. Here theta is a differential operator and z is a independent variable. Okay, and xd equals to theta, x square d square equals to theta of theta minus 1. Now we'll write in terms of theta and z. We'll write the Cauchy's equation. We'll replace x square d square in terms of z. Okay, in terms of z and theta. We'll write just this equation in terms of z and theta simply. This equation becomes, replace x square d square by theta into theta minus 1 plus 3 into replace xd by theta plus 5 equals to 5 into y, right? Equals to x. Replace x by e power z into cos. Replace log x by z plus 3. Then theta into theta, theta square minus theta plus 3 theta plus 5 into y equals to e power z cos z plus 3. Then theta square minus theta plus theta is 2 theta plus 5 into y equals to e power z into cos z plus 3, which is in operator form. F of theta into y equals to function of z and constant, function of some constant function we can say, right? Which is in operator form. Where f of theta equals to theta square plus 2 theta plus 5. Now let's find the general solution to the given equation, which is given by y equals to yc plus yp. Now we need to find yc and yp. The auxiliary equation is f of m equals to 0. Then f of m, where f of m is, we have f of theta theta square plus 2 theta plus 5. Let's replace differential operator by m, so that we'll get f of m equals to m square plus 2m plus 5. Now our auxiliary equation becomes m square plus 2m plus 5 equals to 0. Now let's find roots of our auxiliary equation using m equals to minus b plus or minus square root of b square minus 4ac by 2a, quadratic formula. Just compare this equation with quadratic equation in m. Then a equals to 1, b equals to 2, c equals to 5. Now replace the values in this formula. We'll get minus 2 plus or minus square root of 2 square minus 4 into 1 into 5 by 2 into 1. This is equals to minus 2 plus or minus square root of 4. Minus 4 5 is 20 by 2. This is equals to minus 2 plus or minus square root of 4 minus 20 is minus 16 by 2. Right? Now, we can write minus 16 as minus 4 into 4, right? Or split minus 16 as minus 1 into 16. Now replace or just split square root of minus 1 into square root of 16 as square root of minus 1 into square root of 16 by 2. Since we know that square root of minus 1 is I and square root of 16 is 4. So we'll get minus 2 plus or minus I 4 by 2. Now take 2 common in the numerator. We'll get 2 times minus 1 plus or minus I by 2. Right? Minus 1 plus or minus 2I by 2. 2 gets cancelled and we'll get minus 1 plus or minus 2I. A pair of complex conjugate roots. Therefore, m equals to minus 1 plus or minus 2i is a pair of complex conjugate roots. Of our auxiliary equation. We know that a plus ib is a complex number and its conjugate is a minus ib. If a minus ib is a complex number, then its conjugate will be a plus ib, right? We can call a plus or minus ib as a pair of complex conjugate roots, right? When we have complex conjugate roots, a pair of complex conjugate roots, YC looks like e power a into independent variable into one constant cos b into independent variable plus c2 sine, another constant sine b into independent variable. Our complementary function looks like y is equals to e power. For a equals to minus 1, we'll get minus 1 into z into one constant into cos. For b equals to 2, we'll get 2 into z plus c2 sine 2 into z. This becomes e power minus z into c1 cos 2z plus c2 sine 2z. Now we need to write in terms of x, right? For that purpose, we'll just replace, okay? We'll replace e power z by x and z by log x. Okay. In order to replace e power z by x, here we'll write e power minus z as e power z power minus 1 into c1 cos 2z plus c2 sine 2z. Now replace e power z by x, we'll get x inverse into c1 cos 2 into, replace z by log x, we'll get log x here, c2 sine 2 into log x. We know that x inverse is reciprocal of x, 1 by x into c1 cos 2 We can write log x as log x to the base e plus c2 sine 2 into log x to the base e. So these are required yc. Now let's find yp. Particular integral. We'll find particular integral using 1 by f of theta into q or RHS part. We have RHS part e power z cos z plus 3, right? And also f of theta is theta square plus 2 theta plus 5. We can write this as 1 by f of theta into e power z cos z plus 1 by f of theta into 3. So this is of 1 by f of theta into e power az into v form, and this is of 1 by f of theta into some constant, right? We can write constant into e power 0z. Okay, let's find each term separately. So first one, 1 by f of theta into e power z cos z. This is 1 by f of theta into e power az into v, right? Into v form. Shift e power az towards left by replacing theta with theta plus a, and later we'll operate v with 1 by f of theta plus a. Just compare e power z with e power az, then for equals to 1 we'll find d plus a, which is equals to d plus 1. Sorry, we'll find theta plus 1. Here theta is a differential operator. Now shift e power z towards left by replacing theta with theta plus 1. We'll get theta plus 1 whole square plus 2 into theta plus 1 plus 5 into cos z. This is equals to e power z into 1 by, expand theta plus 1 whole square, will get theta square plus 1 plus 2 theta plus 2 theta plus 2 plus 5 into cos z, right? Which is equals to e power z into 1 by theta square plus 2 theta plus 2 theta is 4 theta plus 2 plus 1 3, 3 plus 1 5, 8 into cos z. And this is of 1 by some function of theta into cos az form, right? Then for a equals to 1, we'll find theta square, which is given by minus of a square equals to minus of 1 square equals to minus 1. Now, let's see what happens if we replace theta square by minus 1 in the denominator. The denominator must be non-zero. I'll take the denominator part, theta square plus 4 theta plus 8. And I'll replace theta square by minus 1. I'll get minus 1 plus 4 theta plus 8 equals to 4 theta plus 7, right? Which is non-zero. Since the denominator is non-zero, by replacing theta square by minus 1, so we can dare to replace theta square by minus 1. What happens if the denominator is 0? We'll get 1 by 0 into cos z. Since 1 by 0 is undefined, so total term becomes undefined. So always remember that the denominator must be non-zero. Now, replace theta square by minus 1. And this becomes e power z into 1 by minus 1 plus 4 theta plus 8 into cos z. Is equals to e power z into 1 by 4 theta plus 7 into cos z. Is equals to e power z into, see in the denominator we have 4 theta plus 7, right? Now, just replace this plus by minus, then we'll get 4 theta minus 7 Now multiply and divide 4 theta minus 7 to this fraction. We'll get and this becomes e power z into 1 into 4 theta minus 7 is 4 theta minus 7 by 4 theta plus 7 into 4 theta minus 7 into cos z. This becomes e power z into 4 theta minus 7 by this of a plus b into a minus b form, so we can write it as 4 theta whole square minus 7 square into cos z. This is equals to e power z into 4 theta minus 7 by 4 theta whole square is 4 square 16 into theta square minus 7 square is 49 into cos z. Again, theta square appears in the denominator, so what we have to do, we have to replace theta square by minus 1. First, we will check what happens if we replace theta square by minus 1 in the denominator. I'll take the denominator part. This is equals to 16 of minus 1 minus 49 is minus 16 minus 49. It is minus 65, non-zero. So we can replace theta square here. Replace theta square by minus 1. Then this becomes e power z into 4 theta minus 7 by 16 into minus 1 minus 49 into cos z. Which is equals to e power z into 4 theta minus 7 by minus 16 minus 49 cos z is equals to e power z into 4 theta minus 7 by minus 65 into cos z. Now we can split this fraction as e power z into 1 by minus 65 into 4 theta minus 7 into cos z. We can write 1 by minus 65 as minus 1 by 65 into 4 theta minus 7 into cos z is 4 theta of cos z minus 7 cos z. Okay, this equals to minus e power z by 65 into 4 into, we know that theta is a differential operator, just replace it by d by dz for our convenience, okay? Minus 7 cos z is equals to minus e power z by 65 into 4 into, derivative of cos z with respect to z is minus sin z minus 7 cos z. This is equals to minus e power z by 65 into minus 4 sin z minus 7 cos z. Now take this minus inside the brackets. We'll get e power z by 65 into minus plus 4 sin z minus into minus plus 7 cos z. Now let's write the terms. Let's write this in terms of x. We need to replace e power z by x and z by log x or log x to the base e. Then this becomes x by 65 into 4 sine. Replace z by log x to the base e plus 7 cos of log x to the base e. So this is the result obtained for the first term. Now let's find the second one. Now coming to the second term, 1 by f of theta into 3. We can write 3 as 3 into x, right? Now take this towards left. We'll get 3 into, it's e power 0 z, not e power 0 x. F of theta equals to theta square plus 2 theta plus 5. We need to find f of a. For a equals to 0, we'll get f of 0 equals to 0 square plus 2 into 0 plus 5, which is equals to 0 plus 0 plus 5, which is equals to 5. A non-zero number, right? So the denominator is non-zero by replacing theta by 0. So we'll replace theta by 5 in the denominator, since f of 0 is non-zero, then this becomes 3 into 1 by 0, or 0 square plus 2 into 0 plus 5 into e power 0x, which is equals to 3 into 1 by 5 e power 0x, which is 3 by 5 into e power 0 into x. We know that e power 0 into x is e power 0. Also we know that e power 0 is 1. So we'll get 3 by 5 into 1, which is 3 by 5. Okay, this is the result obtained from the second term. Now coming to yp. Result obtained from the first term is x by 65 into 4 sine of log x to the base e plus 7 cos log x to the base e, okay, plus result obtained from the second term is 3 by 5. So these are required yp. Now let's write the general solution. The general solution is given by y equals to yc plus yp. We have yc and yp in terms of x, right? We have changed in terms of x, right? So let's replace them. We'll get y equals to yc, 1 by x into c1 cos 2 into log x to the base e plus c2 sine 2 into log x to the base e. Now coming to yp. We need to write yp here. X by 65 into 4 sine of log x to the base e plus 7 cos of log x to the base e plus 3 by 5. This completes the problem. So we have seen a problem from higher order linear differential equation with variable coefficients in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.